Alright, so this problem was like a daily problem a while ago. I was stuck on it for a little bit and then I figured out how to do it. So for this problem we basically have two players, Alice and Bob, and they're in a game where each of them pick a flower at a time to capture it, and when there are no flowers left they can capture the other opponent and then win. And the following rules are here, where Alice takes the first turn, and in each turn a player must either choose one of the lane and pick one flower from that side, and then at the end of the turn, if there are no flowers left in all the lane, then the current player just captures their opponent and wins the game. And then the following parameters are given, like NM. You are supposed to compute like the amount of possible pairs that satisfy the condition of Alice winning the game, and the fact that both your x and y have to be between the range of 1 and 1 and m. So originally I thought that you could use like backtracking to figure out what the amount of possible pairs there could be, but there actually is an easier way, where let's just say, for example, you type in all the possible pairs from, like, let's say n equals 10 and m equals 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let me make this bigger. What? Okay. And then you have the same for m, which is between like 1 and 10. Okay, so one option you can do is to just like go through each pair individually and then check them out. Like go through, let's say, start at 10, let's say that, and then go down between each of them like incrementally, and then like determine if which pair or not like works, I guess. And to determine how each pair works, I knew that if somehow these field of rows were equal to an odd number, so let's just say like Alice was over here, and then, sorry, my drawings are pretty bad, and then that's Bob. Oops. And then there were like 3 flowers. Alice would take 1, Bob would take 1. Bob would take 1, then Alice would take 1, and then Bob would take 1. Wait, no, hold on. No, okay. So let's say it's even, right? Alice would take 1, Bob would take 1, Alice would take 1, Bob would take 1, and then Alice could go in and finish off Bob. So theoretically, as long as there isn't, as long as the sum of your numbers are even, then that would be an option that Alice would have to, like, I guess, figure out how to capture Bob. And originally I was going with this original backtracking strategy to try to catch whether or not, like, whether or not Alice could win, and then like return like the size of that vector. But there's actually an easier way to do this that is a little bit intuitive. So instead of doing the backtracking, notice how they want you to return a long. For further test cases, that would indicate that you would deal with like very large numbers, very large test cases, and etc. So you have to figure out a way that probably doesn't involve recursive or looking through like a large amount of lists, and find a way to computationally like sort of return it, because simply just because of the long. Since backtracking would not work with like big integers, like let's say if you were given 30, you would have to go iterate through it 30 times like 10, so it's like 300 times, which isn't as good, especially since the fact that I believe there is a constraint. Oh no, there isn't. No constraint on the time, but still. like in the future, it would be nice to know. So in any game where Alice would win, there would have to be, wait, hold on, let me double check this. Right. So any game where any game where Alice would win, there would certainly have to be like an even amount of. Sorry, I'm just gonna type it. Honestly, I am losing my mind. There would have to be an even amount of flowers between both sides of the fields, actually, because let's say there's 8, right? She would take. No, let's say even there's 2. She would take 1, then Bob would take 1, then it would be back to Alice's turn. So eventually, all the pairs have to be an even amount, even amount. So it has to be even on both sides. Notice the pattern between the number of possibilities, right? So let's just start with 2. So you would get there's a connection between 2 and 2 because that's even, then 2 and 4 because that's even, then so on and so on. And if you keep looking at all the even numbers and crossing out the odd numbers, like 1, 3, 5, 7, 9, you would get around 5 numbers, which is about just half of your original starting size. And since you're also including m, that would mean that altogether you're looking for the amount of possibilities between n multiplied by m to figure out how many possible pairs there are. So in reality, you're just taking n multiplied by m and then figuring out how many possibilities you have between them. And since your solution is always going to be, since the amount of even numbers or even pairs, I suppose, in between n times m would be half of it, it would be best to say that it would be divided by 2. And then and then this would be your final answer, because you essentially just discern that half of your sample size will eventually lead to positive and even pairs. That's how I understood it, like when I first did it. And then you can return this, I'm pretty sure. And actually, before I return this, if you can guess what's wrong with this, you're pretty smart. But I forgot, you also need to convert to long, and I believe in C++ it's 1ll, which is a weird name for it, but yeah, this should work. Okay, submit it. Alright, and boom. I guess that works.